Okay, so I got a question from a student earlier today about a question for a homework assignment, which is, let me make sure I've got my pen on right. It is 1715. Essentially, it's a Diels-Alder question. Diels-Alder. Okay. So before I look at the question, let me remind you what's going on with Diels-Alder. So it's a 1,4 addition reaction. What we get with a Diels-Alder, and I think every organic textbook presents this essentially the same way. We have a diene and we have a dienophile. Okay, so what I've got here is CH2, CH, CH, CH2, and CH2, CH2. Okay? And what happens here with this reaction is these electrons come and attack that carbon, these come and attack that carbon, and these go there, or attack that carbon. Sort of depends on how you look at that. All right, and so what's this give us? This gives us a six-membered ring, so watch this. Let's go to a different color. Let's go carbon, 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 right? So it gives us a six-membered ring with a double bond there, okay? So it gives us like a cyclohexene, right? One cyclohexene. So what I'm going to do when I'm doing these questions every time is I'm going to lay the problem out so that I can see the diene in a cis conformation, S-cis conformation, and I'm going to go through and number them. 1, 2, 3, 4. Then I'm going to identify the double bond or the pi system that's going to do the attacking. 5, 6, and I'm going to write them out, and I'm going to lay them out in that orientation. Okay. So, and I know it's going to give me a six-membered ring. I'm oftentimes going to actually write this out while I'm doing the problem, and just force myself into it. All right. So let's come with a different page here. Let's get rid of that. Let's go over and look at the question itself. The question is here, and it says, draw the products obtained when benzoquinone is treated with excess butadiene. Use wedges and dashes and include stereochemistry. All right, so first thing I'm going to do, as I promised, is I'm going to write out, well, there's some black. I'm going to write out 1, 2, 3, bam, bam, and that. And I'm going to know this produces that. Okay? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Go back over the question now and find. Okay, there's my diene, butadiene. So I don't need to add any features to that. But now where's my dienophile? And clearly it's that. I shouldn't say clearly. I should say that's what it is. And hopefully that's obvious, but if it's not, there's your challenge right there. It's that. So let me come back over here and say that my dienophile, let me write this in red, different color. Looks like that. Okay? So what's going to happen is I'm going to get my 1, 2, 3, 4, 5, 6 carbons. All right. So where's my 6? Looks like 6 is also bonded to a carbonyl carbon. Right? So far, so good. And looks like I've got this over here too. Right? So far, so good. That's great. It's going to work wonderfully. However, if we look at the question, it says excess butadiene. And it turns out that, where are we here? Turns out that side was a good dienophile, but so was that side. And so what we're going to find is this is going to go through a second reaction over on this other side. Right, so hopefully you can see that. It's going to give me a six-membered ring over here, and the opposite over here, and then everything in the middle. Okay, so that's the answer. Now, I wasn't super careful about numbering things because, frankly, I used my red pen to do that. So I already have my numbers over here. But if that's confusing, let's go over here and say, well, this was 1, 2, 3, 4. Do you see how it's mirrored over there? 4, and that's my 5 carbon, and there's my 6. Still's 1. Wait, 1's here. 1, 2, 3, 4, 5, and 6, right? Okay, and I guess the last thing I've got to worry about, so that's the answer right here, but the last thing I have to worry about is that this is a chiral carbon, okay? So you see I've got a hydrogen that's coming up here, or it's going down, right? And it's going to be either both up or down, or the other way around, right? I'm sorry, they're both going to be up or they're both going to be down. And this side over here is also going to have the same thing. So we've got a few possible permutations of this. But if they're both up, if all 4 of these hydrogens are up, it's the same thing as all 4 hydrogens being down. All right, so let's say that what we're going to do is we're going to come over here. I'm going to draw this guy, and perhaps you'll see what I mean better when I draw it. Okay, so let's make it easy for ourselves. Make a few 6-membered rings here. Bam. Bam. Okay, some double bonds. These are oxygens. Bam. And bam. And these, let's see, if I have a hydrogen coming out here, another way to write that is that this would be coming out, right? Oops, Control Z. Okay. All right, and Control A, Control C, V. I think I can move this over if I do this. No. Just a minute here. Just a minute here. How do I move this guy over? I don't want to rotate. What I do want to do is move him over here. No. Alright, I'm going to have to draw the whole darn thing over again. I know some of you have already figured this out. Oh, there you go. Okay. Alright, now, if all 4 of these bonds were going behind it, it would be exactly the same thing. But, since we've got things going on both sides, it's possible that those are going there, right? And since this has got 2 planes of symmetry, I don't have to worry about putting them over here as well. So this is the answer. Okay, so hopefully that's going to give us credit for it, and hopefully that's helpful. Okay, so that's correct. All right, well, I hope that's helpful. I think the one thing I'd like to emphasize with Diels-Alder, this is a lot uglier, wow, when I draw my hand in it. The one thing I'd like to emphasize with Diels-Alder is that I'm going to very carefully lay out my template here every time. I'm going to lay out a template every time with all my stuff numbered, and then I've got to discipline myself to go through and look for the diene that can get into the S-cis conformation, and also the double bond or the pi system. It's not only going to be a double bond, it could be a triple bond too. The pi electrons that are going to do the attacking. All right, hope that's helpful. Look forward to working with you more closely soon.